Alright, so I'm going to go ahead and calculate this problem on combustion analysis. And so the reason I'm doing this one as well is because this is a little bit out of the norm of what we discussed today, where now it's not just carbon and hydrogen, but you've got this compound that contains carbon, hydrogen, and nitrogen. Okay, so I'm going to go ahead and state that. So I have a compound that's going to have carbon, hydrogen, and nitrogen. Okay, so now what I want to do is I want to go ahead and find out what substances, what information for those substances do they give me in the problem. So in that first, here part of it, it tells me that it contains 12.923 grams of carbon dioxide. So that's more than likely where I'm going to get my information for carbon. So I'm going to say that I have, once again, 12.923 grams of carbon dioxide. Okay, so now I need the hydrogen, and they do give me the substance water, and water does have hydrogen, so that's what I'm going to use to find the moles of water as I'm trying to find the empirical formula here. So I'm going to go ahead and write down that according to the problem I have 6.608 grams of H2O. And again, I'm going to stress that. Why did I pick that? Because I'm trying to look for, it's asking me to find this empirical formula for a compound that contains carbon, hydrogen, and nitrogen. Carbon dioxide happens to be a compound that contains carbon, so I can take how many moles of carbon I have just by the information they give me of carbon dioxide. Why choose water for hydrogen? Because hydrogen is an element that that makes up water, so I can again extract how many moles I have based on the information that they give me. So now I've got to find what information they give me where I can extract how many moles I have of water. Of nitrogen. So if I read through the question, it tells me that it resulted in 2.501 grams of ammonia. So I'm going to go ahead and write that down. 2.501 grams NH3. Okay, now that I have that, to find the moles, okay, I'm going to go ahead and have to find the molar mass of each of these specific compounds. Alright, so for carbon dioxide, that is CO2. That's 1 mole of carbon, and then 2 moles of oxygen. And I'm going to multiply each of these, as you recall, for molar mass by the mass on the periodic table. So carbon is 12.01 grams and oxygen is 16. It's 15.999, but it's 16. Okay, so now what I'm going to do is I'm going to multiply that. That's 12.01 grams. Okay, 2 times 16, 32. That gives me a molar mass of 44.01 grams per mole. Okay, so now I'm going to go ahead and place this down here using dimensional analysis so that it cancels diagonally. So that you have 44.01 grams of CO2 in 1 mole of CO2. And here in a bit I'm going to go ahead and calculate that, okay? But I'm going to get the rest done. Alright, so same thing with water. So H2O, we've got 2 moles of hydrogen, 1 mole of oxygen. The mass of hydrogen is 1.01. Based on the periodic table, it's 1.007. Rounds to 1. I like to round them to the nearest hundredth. And then oxygen, as we said before, the mass is 15.999. I went ahead and rounded it to 16. Okay, multiply those two. Add them up. And I get a molar mass of 18.02 grams per mole. Okay, so I know that I'm going to have to diagonally cancel that. So in 18.02 grams of H2O, that's per 1 mole of H2O. And again, I'll come back and recalculate, or calculate, I'm sorry, that. So now I'm going to look at ammonia, do the same thing, find the molar mass. It is NH3. So I've got 1 mole of nitrogen. And on the periodic table, it is 14.01 grams. And then 3 moles of hydrogen at 1.01 grams, as we had established before. So that's 14.01 grams. 3 multiplied by 1.01 is 3.03 grams. Okay, add them up. 17.04 grams per mole. So I'm going to go ahead and find the moles by placing this diagonally so it can cancel. And 1 mole of NH3. Okay, so just a quick reminder, canceled like units, these get canceled, and so I'm going to multiply across, divide by the bottom. Okay, anything I'm multiplying across, if you see in these 3 circumstances, they're all by 1, so it's going to be the same thing. Okay, so it's going to be 12.923 divided by 44.01. Okay, that's going to give me 0. And let's see, there's 5 significant figures in the given number, so that's how many significant figures I'm going to use. So it's 0.29363. 29363. Alright, there it is. 5 significant figures. Alright, gonna do the next one. 6.608 divided by 18.02. That's gonna give me 0.3667036662. I'm gonna go ahead and use that 4 significant figures, so it's gonna be 0.3667. And again, these are moles of CO2, moles of H2O, and then I'll go ahead and do that last one. 2.501 divided by 17.04, and you're going to get 0.1468 moles of NH3. Okay, so I'm taking it one step back from what you saw in class, because if you notice on the dimensional analysis in class, I had that extra step, and I just wanted you guys to see that when I do it here and I stop here, I get the moles of that compound. But what I really want is I want the moles of that element. So just to break it down a little bit for you, here's what I want you to understand. So I've got one, I'm looking for carbon, so I know that there is a subscript of 1. So I know that subscript of 1 means 1 mole. So in 1 mole of carbon dioxide, I'm going to have 1 mole of carbon. And then I'm going to calculate that, right? Okay, do the same for water. I want to find just hydrogen. So I know that in 1 mole of water, I have 2 moles of hydrogen because of that subscript 2. Okay, so now here I'm looking or focusing on nitrogen, and I know that in 1 mole of ammonia, I have 1 mole, because it's a subscript of 1, of nitrogen. So with the exception of the hydrogen, these first 2, carbon and nitrogen, I know because it's a 1-to-1 ratio, the answer is going to be exactly the same. So I'm going to go ahead, for purposes of space, let me go ahead and start writing right over here. So as I said, right above here, because it's a 1-to-1 ratio, that number is not going to change. So I can say, once I cancel this, that's going to give me moles of carbon. So I can say that I have 0.29363 moles of carbon in this compound so far. And then for this one, yeah, I'm going to have to do a little bit of math. So I'm going to go ahead and multiply that 0.3667 by that 2 and then divide it by 1, which we know is the same, right? So it's 0.3667 times 2. Okay, that's going to give me a grand total of 0.7334. So 0.7334 moles of hydrogen. And why? Because I'm canceling the moles of water and I'm left with moles of hydrogen as my remaining unit. Okay, so now same thing here. Cancel like terms. Remember that 1 over 1, same thing. So I'm just going to go ahead and say that that times 1 is the same thing. So that's going to be 0.1468 moles of nitrogen. Okay, so now I've got my list of moles for each of these elements. And remember that when I'm trying to find empirical formulas, the next step at this point is for me to select the smallest of the 3 numbers. Okay, so I'm selecting the smallest of the 3 numbers. And in this situation, it's going to be the one for nitrogen, the 0.1468. So what you're going to do is you're going to divide all 3 of them by 0.1468. So that divided by 0.1468, 0.1468 divided by 0.1468. Okay, obviously, since this is the same number, bam, it is 1 mole. Okay, for this one, we're going to calculate it. So that's 0.7334 divided by 0.1468. Okay, that's going to give me, if you could see on the calculator, 4.9959. So I can easily say that it rounds to a 5. So I'm going to say that this is 5 moles. Alright, I'm going to go ahead and go to the next one right above it. It's going to be 0.29363 divided by 0.1468. And if you could see on the screen, it says 2.0000000200436. Sorry, and so I can pretty much say that that rounds to the whole number 2. So that's going to be 2 moles. All right. Notice that in this situation, guys, there were no numbers that were sort of close to a whole number. So we don't have to multiply by another number to get it closer to a whole number. They're set for us. So in this case, carbon will have a subscript of 2, hydrogen will have a subscript of 5, and nitrogen would have a subscript of 1. But remember, we don't show ones on the formulas. We just leave it as is and assume that it is 1. Okay, guys, that is the empirical formula using combustion analysis. And see, we didn't have to go further, but that's pretty much it. And we're done with this one.